Okay, so start the recording. So Year 9 Maths 2020, we're going to talk today about some basics of fractions and simplifying fractions. Many times when students are working with mathematics, one of the problems that they have is that they don't recognize certain terms or phrases, so they don't quite understand what it is they're being asked to do. So we're going to talk a little bit about some basics of fractions and some information about simplifying fractions. And again, we're just going to go through some definitions from the book. I expect you to write these down. And of course, we'll be looking at your notes before we leave the class. So let's just go to the book. Sorry, there we go. All right. So we're talking about fractions and rational numbers. Now, when you're talking about fractions and rational numbers, so rational numbers, anytime you see that word rational numbers, you should think fractions. And the reason they're called that, so you should make sure you write down rational numbers, and then we'll talk about the definition. It's simply a ratio of two integers. In other words, a fraction. Now, fraction is not the only way to write these. You'll see different forms. There are lots of different forms for rational numbers, but all of them can be written as sum A over B, as long as B is not 0. Because remember that if you have the denominator 0, it makes the fraction undefined. You can't divide by 0. Okay? So they can look up at several different forms for rational numbers. And we're going to write each one of those as a fraction. If you have just plain 4, for example, any whole number can be written as a fraction by simply putting it over a what, guys?
10 or 100?
Yeah, 1. There you go. Be careful. Because we're talking about just a whole number. So any number divided by 1. Okay? Now, doesn't matter if it's negative. So you have -2 to write it as a ratio or a fraction. We'd simply put it over a what? A 1? Okay? We can even do that with 0. 0 over 1 is the fractional form of 0, because 0 divided by anything is still 0. Okay? Now, what you were thinking about was what happens when you have something like this. Remember that the percent symbol literally means to divide by 100. So if you're changing a percent to a fraction, that just means you're going to put the number of percent over 100. Okay? And, of course, we all know that that is not simplified, is it? Simplified means divide away anything that's common to the numerator and denominator. And both 10 and 100 will both divide by what number?
10.
10. Excellent. So we'll divide the top by 10 and the bottom by 10, which gives us 1 over 10. And the answer is not correct unless it is simplified. Okay? Now, -4 over 7 is already a rational number. Okay? So the thing about that one is that you need to be aware about what happens to the sign. The sign is in front of it, right? But when you have a rational number, you can have a couple different ways of doing this. We could put that negative in the numerator. So -4 divided by 7 is the same as -4 over 7. Or we could put it in the denominator. Now this one is the preferred one. So if you have a negative in front of a fraction, that's the same as saying that the numerator is a negative. Okay? And this one is the one that's the most important to us at this particular moment in time, because we're going to be working with lots of sign numbers. So if you're going to work with a problem, okay, and you need the sign in a different spot, you'd move it from in front of the fraction up to the what part?
Numerator.
The numerator. Good. Now I could put it in the denominator, but the preferred form is in the numerator. Okay? All right.
What's the difference of having it on the outside of the fraction or in the numerator section?
Well, yeah. The difference is that this form, okay, is perfectly fine most of the time. But what you're going to see, and for simple fractions like this, that's perfectly fine. But what's going to happen is later, you're going to get to have some fractions that look like these. And then that negative, that in front of it, has to go up into the numerator before you can do any math with it. Okay? It's just about, this is, so right now when the fractions are small, when it's just a fraction, who cares? But when it becomes a fraction, an algebraic fraction, okay, then it matters. So we just need to be aware that that of the different ways it can be written. Okay. Also, sometimes you might be doing some math, okay, and you end up with something like negative 2 over 3. Well, negative 2 over 3 is perfectly fine, but it's not the I almost said it. It's not the prettiest form. It's not the best form it can be. Because negative divided by a positive just makes the entire fraction negative. So this is the way you'd want to write it. This is the way you use it when you're doing the math, but when you get your answer, you want that negative to be up front. Because literally you need to perform the division to simplify it, and a negative divided by a positive makes the whole fraction negative. Okay? So when you're using it, negative in the numerator. When you're writing your answer, negative out front. Make sense? Okay, so this is when we're using it, and this is when we're writing it as our answer. And again, as you move forward looking at signs, you're going to see lots of these. Okay? All right. Let's look at the next one. So we did that one. So 1. How can I write 1 as a rational number? Any whole number can be written as a rational number. I was putting it over what?
1.
Over 1. So 1 over 1 is the same as 1. Okay? So 1 is equal to 1 over 1. Okay? Now, that's a good one. I just threw that one in there, but make sure that you know that one. All right? When you have decimals, remember that decimals, the decimal place will tell you what to do. So that 3 is in the tenths place. You agree? So all you have to do is, if you can name the decimal, then you know what fraction it's going to be. Now the 1 is a whole number, so it's not going to change, okay? But you can put it over as tenths. So this can be written in a couple of different ways. 1 and 3 tenths. So if you know the name of the decimal, and 1 is the same as 10 tens, so that can be simply written as 13 tenths. You just have more than, the numerator is bigger than the denominator. Okay? Right. Now, then some decimals will reduce, and they are a little funny because this one has that bar over it. What does the bar over it mean? That it's a repeating decimal, right? And so they have some slightly different rules, because instead of just being able to name it as 6 tenths, it's not really 6 tenths. It's really 6 over 9, and then it reduces. Okay? And don't worry too much about these. I don't see much reason for you to convert those, but we'll talk about those rules later if we need to, okay? Or if you just get a hankering to look it up, you can. But if it's repeating, then it's never going to be a tenth or a hundredth or whatever. It's going to have a denominator of 9. It doesn't quite get there, right? Okay? All right. So There are lots of different ways of writing. So those rational expressions, those are fractions. The top number is the what?
Numerator.
Numerator. And the bottom number is the denominator. Good job. And we usually just use capital N over D. Okay? And there are some different types of fractions and some things that we need to talk about with fractions. A common fraction is simply just what you'd think of, a numerator over a denominator, where the numerator is always smaller than the denominator. Okay? And they are always simplified. So you wouldn't have 5 over 10. Both of those would divide by 5, which would give you what fraction? Not getting answers. I'm getting cereal, but I'm not getting answers. 1/2, right? Okay, good job, guys. Okay? All right. Another thing that you're going to need to know about fractions, and we're going to talk about fractions, is the idea of a reciprocal. And anybody remember when you need the reciprocal? Which operation with fractions uses a reciprocal? Which of the 4 operations? Do you remember? Add, subtract, multiply, or divide? Divide. When you divide fractions, you need a reciprocal. Exactly. And the reciprocal of any fraction just means to invert it, flip it over. So the reciprocal of A over B is simply B over A. Okay? So occasionally you'll be asked to use the reciprocal, so you need to know that word, reciprocal. And if you have the reciprocal, all that means is to flip it over. Literally, it means the number you would multiply to get a 1. Because if you took A over B times B over A, you would get AB over AB, and anything over itself is what?
1.
So literally reciprocal means the number that you would multiply times any number to get a 1, but you just find it by flipping it over. Okay? So reciprocal. Right? Now, let's talk about the different types of fractions that you're going to see. A proper fraction just means the numerator is less than the denominator. Those are just common fractions, right? An improper fraction, remember you're supposed to be writing these down, not just underlining like I'm doing. Okay, the numerator is less than the denominator. An improper fraction, the numerator is greater than the denominator. Okay, a mixed number is a whole number and a fraction. So I'll write in the ones that I don't think they give you a good definition of. So it's a whole number and a fraction. And it literally means those two pieces are added together. So 2 and 1/2 is the same as saying 2 plus 1/2. Okay? And for the lesson today, the first part of it we're going to talk about is talking about what are called equivalent fractions. And equivalent fractions mean they both represent equivalent portions. In other words, they're the same size. It's just that the numbers look a little different. Okay? So 1/3 and 2/6 are equivalent fractions. One of those, there's something wrong with it. Which one am I unhappy with? 1/3 or 2/6?
2/6.
Exactly. Because it's not simplified. We would not leave it in that form except under very certain circumstances. This would be your answer, 1/3. 1/3 is the way you should write your answer. But there are times when you would need an equivalent fraction with a bigger or a different denominator. Okay? So, all right. So let's talk about equivalent fractions a little more. And you'll see that There are some notes here for you. So equivalent fractions, to find equivalent fractions, you need to multiply both the numerator and the denominator by the same amount. If you're given two fractions that are supposed to be equivalent, find the missing number first by working out what the other number has been multiplied by. And you can always find multiplication by using the opposite of multiplication. What's the opposite of multiply?
Divide.
Divide. Excellent. So let's just go through the example that she's given you there. So we have 7 over 9 equals 21 over something. Now here we're missing this denominator, right? But because of this equal symbol, we know that these two are equivalent. So I multiplied the 7 by something to get a 21. So 21 divided by 7 is what number?
3.
And if they stay equal, the only way for that to happen is that the top was multiplied by 3 and the bottom was also multiplied by 3. And the reason we can do that is because what is 3 over 3 equal?
1.
1, exactly. So you're really multiplying by 1, which changes the way the numbers look, but it doesn't change the values. So what is 3 times 9 going to make down on the bottom?
27.
27. There you go. So our equivalent fraction is 21 over 27. And you can always check it because this should reduce or simplify to give you that. They're the same fraction. Okay? So you're going to have an exercise where you're just going to be finding out what you multiplied by and then multiplying it. And we'll look at the lesson so you can make sure that you understand what I mean about that. Okay? We're also in this lesson going to have some fractions where we need to simplify the fraction. And we've talked about that one a little bit earlier, a moment ago. And that means to simplify means to write it in its simplest form by dividing away common factors. So you're just simply going to divide numerator and denominator by common factor. Now remember, if it's common, that means it will divide evenly into both of them. And as you see through the example they give you, because this one has a pretty big number. We have 84 divided by 96. They divided it by 2, then they divided by 2 again, then they divided by 3, and then they finally get to this most simplified form. And that's a process that is perfectly acceptable. Now, if you take 2 times 2 times 3, you'd get 12. So if you know your multiplication tables really well, you might have noticed that both of these would divide by 12 right away. And if you did, you'd get straight to the answer. But if not, it's perfectly acceptable to take it in pieces. What do you think is more important, to do it quickly or to do it accurately?
Quickly.
Do it accurately.
Accurate.
You brat. Yeah. Accurately. So you can do it piece by piece. Now, I'm going to show you a little method for when you have big numbers that really works well to keep you organized if you have lots of different division to do. And I might have shown you this before with the upside down division symbol thing. You notice that both of those will divide by 2, right? So divide them by 2, you get 42 and 48. Those will still divide by 2, so I divide again, which gives me 21 and 24. Those won't divide by 2, but they'll both divide by 3, which gives me 7 and 8. And 7 and 8 won't divide by anything. So remember, this was your numerator, this is your denominator. So this one is still your numerator, that one's still your denominator. My completed answer is 7 over 8. Using that upside down division is just an organized way of being able to do really large numbers. Okay? And staying focused. Because what we're doing is we're just tossing out these common factors. We don't need them. It means the fraction was too big. Now, you don't have to do it that way. You can just do it like they did. Just divide again, divide again, divide again. Whatever method you like is perfectly fine with me. Okay? All right? And again, if you see another number, so for example, when you got to, scroll a little bit. So if you had seen the original numbers and saw they both divide by 4 and you divided by 4, so you can divide by anything you want to as long as you continue to divide until it's all done. So you see here, this shows you what happened if you just divide them both by 12 originally. You get to the number really quickly. But again, the whole point is to get the right answer, not the fast answer. Okay? How's all that look? Pretty straightforward. So mathematically, I don't think you've seen anything new. The only thing I think that any of you, if you have a real issue, would be here when we're talking about the words, right? So make sure that you have the vocabulary, right?
The only thing I haven't
critical.
Seen before is the reciprocal thing.
Ah, really? Okay, the reciprocal. Yeah.
Well, I know I've done it before, but I just never heard the word.
Oh, wow. Okay, good. Well, excellent.
I never called it a reciprocal fraction. I can't remember what I called it, but it wasn't that.
Yeah. Okay. It may have another word, another definition that you all use, but I don't think so. Anybody else ever heard a different definition for reciprocal? Or have y'all always just said invert and multiply or something like that?
Because I've been to an American school and then a British school, so I had several names for them.
Okay.
So I can't remember what it is now, but it wasn't reciprocal.
Okay. Well, if you think of it, let me know. I'm curious. That would be interesting to me. Thank you. Okay, so what I'm going to do is I'm going to end the recording here.